The MiniSTAR and BioSTAR use positive pressure, which gives you superior adaptation to your model, ensuring the accuracy and fit of your appliance. These machines can significantly reduce your lab expense by increasing the variety of appliances you can do in-house. Most of the technique videos in our Resource Center feature the BioSTAR because that's what we use in our commercial lab at Great Lakes. For most dental practices, the MiniSTAR is ideal. You can use the MiniSTAR to fabricate the same extensive variety of appliances that you can with the BioSTAR.
Before the transverse expansion screw is placed, the midline of the arch is established. Draw a reference line through the center of the arch with a number 2 pencil. Also identify the anterior-posterior position of the expansion screw by placing a transverse reference line at the second bicuspid region. The midpoint of the expansion screw will be referenced at the intersection of the 2 reference lines for the upper arch. A slotting burr and lab hand piece is used to create a groove in the center of the model along the center reference line. This groove will hold the plastic tab of the expansion screw in its proper position. Remove model dust and place the tab of the expansion screw into the model slot. The screw tab should fit loosely within the slot. The arrow of the expansion screw should point to the heel of the model. Cut the tab as needed to allow screw to fit closer to the tissue. A 1 to 1.5 millimeter gap should be present between the model and the screw body. Apply hygienic baseplate wax into the slot of the model. Slots should be about half filled with wax. Place the tab of the expansion screw into the soft wax within the model slot. The screw body should be referenced level to the occlusal plane and center opening or tab aligned with the midline reference. Remove the expansion screw from the center slot and apply liquid separator with a brush. Place the screw back into the model slot and secure with wax. Make sure the original reference position is established. Secure the wirework in place with wax along the facial surface of the model. Apply polymer powder and monomer liquid using the salt and pepper technique to flow under the expansion screw. Once this resin is cured, it will stabilize the screw's position during the pressure molding process of the retainer plate. Place the model and acrylic resin into a humid pressure pot for 15 minutes. Pressure should be adjusted to approximately 20 psi. At the end of the curing cycle of the resin, evacuate the pressure from the pot. Remove model and cured acrylic. Remove the expansion screw tab with wire cutters. Cut the tab close to the top of the screw. Adjust pellets within the cup to elevate the model. For a Hawley retainer, the top tooth surfaces should be at the height of the cup's rim. Fill the gap between the model and the cup's rim with pellets. Sweep excess pellets with a 1-inch brush. Pellet level should be against the occlusal tooth surfaces and heel of model, and extend to the rim of the cup. Make sure the pellets are removed from the cup's rim. Select a 2mm BioAcryl disc. A variety of colors and pattern designs are available. Clamp the BioAcryl disc onto the chamber. Identify the material's heating time or MiniSTAR code and enter it into the machine. Swing the lamp over the clamp material to start the heating cycle. With 45 seconds remaining in the heating cycle, mix monomer liquid and polymer powder to a maple syrup consistency with a No. 7 spatula. With approximately 20 to 30 seconds remaining in the heating cycle, apply resin over wires and expansion screw. Heating cycle and resin application should conclude at the same time. At the end of the heating cycle, swing the lamp to the back of the machine. Swing the chamber over the model in the pellet cup and lock the chamber in place and cool under pressure for 2.5 to 3 minutes. During this phase, the applied resin will cure. At the end of the cooling and curing cycle, evacuate the pressure from the chamber. Unlock the chamber and clamped material. Swing open the chamber and remove formed material and model from the pellet cup. Some pellets may stick to the formed material. Remove pellets with lab knife. Then loosen the wires that were held in place with wax along the facial surface of the model and remove formed plastic. Using a carbide cutting burr and lab handpiece, cut out the retainer from the disc. Start by cutting along the back of the appliance at the first or second molar reference. Then cut along the lingual cusps of the posterior teeth and near the incisal edges of the anteriors. Caution must be used around wires that are embedded in plastic. Once the cut has been made in the plastic, remove the retainer from the disc. The posterior segment is scalloped 1 1/2 millimeters above the gingival margins to rest against the cervical crown surface and rounded to the interdental papilla height along the anterior dentition. This is accomplished by using a carbide cone or taper burr and a lab handpiece. The back or heel of the retainer is often tapered forward near the mid-palatal area. Maintain plastic contact against the last tooth on each side of the arch and taper acrylic forward about 1/4 of an inch. Finally, the scalloped posterior and rounded anterior segments are blended into the retainer body. The expansion screw cut is made through the center of the plastic plate. Place a reference line onto the plastic along the midline. Using a 3/4 or 7/8 inch diameter lightning disc and lab handpiece, incorporate a center cut in the plastic along the reference line. Then expose the keyhole of the expansion screw using a cutting burr and lab handpiece. Insert a wire key into the hole of the screw and rotate it in the direction of the arrow on the screw body. Activate screw approximately 10 turns. Remove the plastic tab in the center of the screw with a lab plier. Smooth the plastic along the center cut with a cone burr, then sandpaper mandrel and lab handpiece. Keep screw in open position through all remaining steps. Close screw after pumicing and polishing process. This retainer is pumiced and polished using the same procedures outlined for the upper Hawley retainer.
These technique videos, along with the other information on the Resource Center, can show you how to get the most from your machine and how to ultimately take control of your lab bill. Maximize the potential of your MiniSTAR.